Hello my dear science nerds and welcome to my channel Let's Chemistry. The materials presented in this video are only for educational purposes. We are excited to start experimenting with vanillin and eugenol demethylation reactions. For this purpose, we need significant quantities of bromine. Being a halogen, bromine atoms are one electron short of a complete outer shell, which makes them highly reactive. This preparation must be done under a fume hood or outdoors by the experienced chemist. At room temperature, bromine is a red fuming liquid. Like other halogens, its smell resembles iodine and chlorine. Bromine is quite dangerous chemical. While handling bromine, personal protection measures like gloves and glasses must be used. Bromine can cause severe skin burns. From many different techniques of bromine preparation, we have found Chemplayer's method to be the most original. They had used ammonium persulfate as an oxidizing agent. In our experiment, we will slightly modify the procedure. The reaction is radical initiated. Let's check the reaction equation. Ammonium persulfate is added to the potassium bromide to form free bromine and the solution of ammonium and potassium sulfate salts. For the beginning, we need to weigh out 200 grams of potassium bromide in the beaker and add boiling water. We need to use minimal amount of water. The final volume of the solution is approximately 300 milliliters. We place the solution to the 1 liter round bottom flask. Now we need to dissolve in the boiling water 250 grams of ammonium persulfate, and again 270-300 milliliters of the concentrated hot solution is obtained. We have assembled the apparatus. Unfortunately, we have a shortage of 2 and 3 neck flasks and had to use the Claisen adapter. We add the persulfate solution to the 500 milliliters pressure equalized addition funnel. The regular funnel wouldn't work because the system must be maintained sealed to prevent the bromine vapor from escaping. Despite having fume hood running all the times during the experiment, even a small leak of bromine is very unpleasant and dangerous. All joints are greased with a resistant, heavy-duty lubricant. You can also use sulfuric acid to grease the joints. Regular grease, if it interacted with bromine, would be destroyed very fast and small chemical disaster in lab would become unavoidable. The second neck of the Claisen adapter is connected to a simple distillation setup. Small 250 milliliters collecting flask is submerged into the salted ice. It is very important to keep bromine cold to minimize evaporation. Ice-cold water in the condenser is a mandatory. The vacuum adapter is connected to a tube going to a hole in the window. Double check the contacts of all the joints once again before starting persulfate addition. Once we are ensured that everything is in order, we add a good third of the liquid from the addition funnel. Now we have to wait for the reaction to start. Almost immediately, the liquid has changed the coloration and has become reddish orange. The liquid in the flask starts to boil. The reaction is exothermic. Despite the clear signs of reaction going, the bromine is not distilling over, so we decided to add a little more. It is a mistake because we had to wait for the reaction to fully start before adding more. As you can see, the things almost got out of control and the condenser was almost overwhelmed. After that, we will proceed slowly. Each addition of an oxidizing agent causes a large portion of bromine and water vapors to shoot out of the reaction flask to the condenser. It takes a few minutes to cool a little bit down before the next addition. At the end of the addition, we have applied a heat. We wait until no more bromine drops are collected and we cool down the system. A bromine freezes at -7 degrees of Celsius, and unless you are using sealed ampoules for storage, freezing is the best way of storing it. We stopped the collecting flask and stored it in the freezer until the next day. We also put 100 milliliters of sulfuric acid to the freezer. On the next morning, we are continue and now we need to dry the bromine with concentrated sulfuric acid. We have chilled down the acid at -25 because it becomes extremely hot in contact with water and can easily cause bromine to boil. Bromine is not melting easily, and we decided to help it a little and added little sulfuric acid to the flask. Almost everything has melted immediately, and we transferred the bromine water mixture to the separation flask. I don't have an answer why we have not used the funnel. Tiny frozen bromine chunk fell out from the flask and started to become a huge problem. I have watched the recording many times to see how did it happen. We decided to show how careful you must be when working with dangerous chemical, and even small mistake can cause huge problems. Fortunately, for the following cleaning of the glassware, we had prepared in advance strong sodium bisulfite solution to neutralize any bromine leftovers. Thanks to it, we are able to contain and clean the spills. The sodium bisulfite solution must be at hand just in case of such complications. After cleaning up the table, we continue with the bromine drying process. We shake it twice with sulfuric acid, and once the layers separate, we drain the lower bromine layer to the storage flask. We had pre-weighted the flask and now are going to find out the yield. We have got 180 grams of bromine, which represents 83% from the starting 200 grams of potassium bromide. Not bad taking into consideration the accident. Thanks for watching and stay tuned.